All right, welcome to the next episode of the AI Rebels podcast. We're very excited to have Jerry Wuan, who is the co-founder and CEO of Halluminate.ai. We're excited to talk about everything they're doing, which is filling a huge gap in the AI space, which is not as well known as it should be, the gap going on there. We're excited to talk about it. Jerry, as a quick background, went to Cornell, got a degree in computer science, did a lot of machine learning research. He actually worked at Capital One Labs, where he helped do LLM research. Make sure I'm getting this all right, Jerry, but you basically led the development of Capital One's first AI agent for their call centers. Is that right?
Yep, exactly.
And that was back in early 2023,
Mm-hmm.
and you've just been crushing it in AI since you graduated. I'm curious. So I think you said you've been in AI since you were at Cornell. What did you? Because that was before the craze. What did you see in AI? Like, what was it that attracted you to this space?
Yeah, totally. First of all, thank you guys for having me here. Super
Yeah.
excited. Big fan of the show and what you guys do, and would love to be part of the community. Secondly, jumping into that question, great question. I think it's not like I didn't have a deep thought out process there. I think it was more just like as a student, I always went around picking courses and majors that I felt had the highest leverage to enable me to do cool things down the road. And, although no one probably could have predicted what the AI field has evolved into, I think most people, if you were to place bets back in early 2020 on like where there would be a lot of leverage and learning skills to build incredible things down the road, AI and machine learning was a pretty safe bet, right? And so as a student, I knew that I wanted to have the skills to eventually be able to at least converse and be familiar in these like really cool topics. And I did computer science. Big reason because I wanted to eventually build cool things, and so I think that's why I was really drawn to learning how to build software and specifically learn how to apply models in business-facing problems.
That's awesome.
It's interesting how often we hear that from our guests that like their original attraction was not necessarily always technical, but oftentimes just like, hey, I want to do cool stuff, and like this is the easiest way and best way to do cool stuff.
Exactly. Literally, like you just kind of see where all the cool things you use in your life are, and you're like, wow, I want to do something like that. And I feel like the curve of innovation has really been indexed on this AI wave, and you can already kind of see it crescenting in early 2020. So yeah, that's what really drew me to that space, and took some early ML courses. And at Cornell, I was really drawn into the world of quantization. Quantization is a specific field of ML where it's just a fancy way of saying making models smaller while still like retaining label accuracy or performance. So, that's, on top of just the coursework I did, I had the opportunity to work under Chris DeSale's lab there, who they were doing some cool work in quantization really early on with like 4-bit and 8-bit quantization methodologies. Field moves fast though, and it's pretty crazy how the stuff that you learn in a research lab in 2020 has basically become close to outdated in 2024. So both a blessing and a curse, I'd say, to do all that deep research.
Oh yeah, for sure. I'm curious, with AI, do you remember the first time you used like the chatbots we have, whatever it was, Chat GPT, anything like that? Do you remember the first time you used that or started seeing it?
Yeah. So honestly, I didn't really start working with language transformers until 2022 when I joined the labs at Capital One, and that was sort of the area where I was exploring. In school, I was doing research more on image recognition and convolutional neural networks. That was, I think, definitely a bigger area of focus in my undergrad studies. So honestly, didn't really realize the nuances of the language model until 2022. And so that's when I first really started getting introduced to chatbots. And even back then, it's crazy how fast the industry moves. 2022, the chatbot industry standard is, what we saw back then, which is like very deterministic, clunky, like you hit a chatbot and it gives like 5 options. You hit one of the 5 and it takes you another 3 options and you hit another option and eventually maybe it takes you to the right answer, but usually no.
Right.
And you go like human, right? So that was my initial just like context on like what I thought chatbots were when I first started working with them. But then, when I started looking at large language models, even the early GPT-3 systems, you quickly saw where the curve was going. And then I think everyone was still surprised when ChatGPT came out, but it was pretty big, welcoming for those systems out that door.
Yeah, ChatGPT blew me away. I had done a little bit of, I had paid attention to the development of the GPT models loosely, GPT-2, GPT-J, etc. Watched like the little Codex demo that OpenAI did. I think that was like a year before ChatGPT came out. But even then, even with that context and having some knowledge of where language models had been and where they were looking to go, it was still mind blowing to me to use ChatGPT for the first time.
It's really got like a demo ability. I think that's something that's super underrated about their release, which was a big part of it was the demo ability and the wow factor, the like instant get it moment. I think another part is like, no, go ahead. Sorry.
Oh, and I was going to say, like, I think that's something that people underrate is the simple UX of streaming the tokens back rather than sending them all up back at once, because that makes it feel so much more magical. Makes it feel like the computer really is like talking back to you rather than
like watching it materialize.
Yeah, like here's an answer to my question 30 seconds after I ask. That's cool. It does it changes the way it feels really significantly.
Totally. And I think you actually hit on something super insightful, which I'm starting to realize, which is I think previous generations of models, their outputs and the tasks they were doing were constrained in like a broader product system. For example, like a recommendation engine was concealed in a search engine. A weather predictor was concealed in a weather app. I think, and it's sort of relevant to the problem space we're solving and one of our unique insights. The really cool thing about language models is the model output itself is the product often, right? Because it's the text itself that is driving the value and driving the user pattern. And so the way that these outputs are being judged and evaluated is almost becoming like a product question and a business question on top of just like a technical and ML problem. And that's something that I learned very quickly building Capital One's first AI agent, which is like historically you could usually, have data scientists evaluate and test outputs of a model, and product people and business people were pretty segregated from that. But with language, now everyone can and should give input on what that output looks like. And that makes the task extremely complex, but also adds a lot of like variability, nuance, and value because, the product itself becomes a lot more robust and where it can be used.
Yeah. Which I think kind of is a segue to Halluminate, right? Where maybe just give us a background on the thought process here behind Halluminate and where this comes in with these LLMs and the gap that you saw.
Yeah, totally. I guess I'll just start from the top and kind of give a quick intro on Halluminate and what we're doing. So at Halluminate, we're building the testing layer for AI agents. Specifically, we're trying to help AI engineering teams build safer AI agents faster by streamlining the testing process with trustworthy evaluation models. So as a handful, we'll unpack that from the beginning. When I was at Capital One, and we were building our AI agent from the ground up back in, again, this was early 2023, when the GPT moment first arrived and everyone was trying to find ways to productionize these systems. We were building a AI agent in the call center space, right? So super clear business value proposition in call centers. This is a pretty mind-blowing stat. Like for some large organizations, every second you can shave off of a call is $1 million, right? And so that's what we were trying to do. However, the thing that I learned very quickly and the team learned very quickly is that building the AI agent is difficult, but testing it, especially in a highly regulated industry, is exponentially more difficult. And specifically testing the output generation itself to validate things like quality and performance, but also compliance, risk, style, tone, right? Because think about it, you're trying to essentially mock a customer servicing agent representative and how they would respond to questions. But problematically, since large language models are non-deterministic, you can't do like consistent regression tests on them, right? Because every output is slightly different. And so we ran into this problem like a brick wall. And the way we had to solve it was essentially through manual data labeling. And the team and I essentially became data labelers for a few months. And it is a really tedious, but it was a necessary process. And so we would print out 1,000 outputs, review them in spreadsheets with various criteria with subject matter experts, grade it, and then repeat the process over time.
So you'd manually you would have a set that you would manually go through and check.
Exactly. It's like manual regression testing. And so that was sort of the operation and, the status quo for us and for many companies as I was talking around. And, you can quickly see how, if companies like Capital One and everyone wanted to scale these systems in a quick and iterative way, this manual testing process just wasn't the right answer. And so we actually explored some automation methods. The first one that everyone looks to, especially in the natural language field, is, the more traditional out of the box calculations of semantic similarity, like cosine similarity or, blue or rouge score, things like that. The problem with these methods is usually one, they're pretty unreliable for answers where you don't have ground truth because they compare similarity between two chunks of text. And so therefore you need to have a pre-written ground truth. And that's a high, initial cost that needs to be spent writing a bunch of essentially ideal answers. And secondly, they didn't often capture semantic meaning very well. So if something is very closely similar, but they're actually saying totally different things, then they would have a high cosine score, but actually not mean the same thing. Great example is like if you had something that's like the sky is blue, and then another sentence that's like the sky is bluish, right? They mean totally different things, but their cosine similarity score would be very similar. But then a real human reading would be like, okay, this is totally
what does that
wrong.
even mean? Yeah,
exactly. And so the second method that is sort of an emerging paradigm, and the space where we're most focused on is called evaluation models. Another way that people term this in the industry is model as a judge or LLM as a judge. And the core principle is basically you take the answer and you ask another foundation model to essentially grade it based off of heuristics and parameters you give it. And it spits back out a confidence score based off of the criteria that you give it. And so this is a super nascent field that's now starting to emerge. I think the original LLM as a judge paper came out in mid 2023 as well. But this has shown a ton of promise in really outperforming and giving people the necessary information they need to be able to robustly test these systems. And so
Wow.
that's the technical background. I can go a little deeper into some other trends we've seen, but we realized this was the problem. There's this new emerging paradigm coming, and we wanted to combine these and try to automate this process or streamline it for a lot of companies that they wanted to scale development. And so my co-founder, Wyatt Marshall, who's also my roommate, and we've been friends since college for like years. We both decided to leave our jobs and start this company a few months ago.
I'd say it's timely. I was literally my little brother works at an AI startup doing, I don't remember exactly, but something to do with sales. And he was just complaining about this exact problem like 2 weeks ago. That pretty much the only way to get really reliable, evaluation scoring right now is to do a lot of the evaluation himself.
100%. And
so super interested to hear more about your approach.
Yeah. And to talk about the industry a little bit, I think evaluations sit in a really interesting space, right? Because if you think about it, testing and evaluations don't really become an issue or a priority for most people until they built something and they're trying to scale it. And so it's really interesting in terms of like the priority curve, and it's kind of reflected by, I think, like where investments are really going in the space, right? Where the most important companies and tools kind of follow the progression of where the majority of the industry is in their build cycle. So it started with obviously infrastructure because everyone wanted GPUs to like test this thing. Then it went to the data because everyone wanted to refine their data to pipe it into their systems. Then it kind of went to like these orchestration tools like Langsmith or Databricks where people try to put them together. And I think now we are just starting to see the focus of the industry fall into evaluations because everyone's like, okay, I've got this thing up and working. I've got it producing outputs and it's, running on GPUs that are fast. Now I need to see if this thing is correct or not to be able to scale it to millions or hundreds of millions of users. And so So for us, when we entered the space, we realized, hey, there's sort of this progression curve. Capital One was definitely further on the progression curve in terms of like financial services industries, but it was still very far behind in terms of startups. And so if you look at this curve, the AI startups are hitting these problems first, and then the legacy industries are following up, right? And so that's actually where we went. And when we first initially started outreach, we were talking to all these banks, and we realized they're still so far behind us that they don't have this problem yet because they're still busy spinning up infrastructure and getting access to an API endpoint that they can hit. And so we actually went, Spencer, to your point, to AI startups. And we're like, hey, let's go to the AI startups. Let's go to the cutting edge, the people who are already far along in productionizing the systems, and figure out how are you guys testing these things at scale. And that's where we learned something really, really interesting, which is when you talk to these cutting edge AI startups, like, for example, Harvey, right? AI legal startup, or like the really, really cutting edge systems players that have been in this space for a while. And you ask them, hey, how are you guys currently testing your systems? The primary mode is evaluation models or models as a judge. And so these cutting edge startups have already started to adopt this methodology. But secondly, what we found out that was a super interesting insight for us is that these companies are currently spending anywhere from 20 to 40% of their inference costs on evaluation models. So what that means is that if they're spending $10 to generate an answer, they're spending anywhere from $2 to $4 on another model to check that answer. And so you can already kind of extrapolate how immense and how valuable and also how specialized that space is going to be. And this kind of leads into like, when we realized that, it was really like, it was a click moment for our team. And we kind of crystallized on our like worldview. And we kind of realized, if you extrapolate this pattern out, we think that the future of inference is going to be dominated by two categories of models. The first category is going to be generalist foundation models that create output. And the second is going to be a specialized set of models that robustly test and assess those outputs. And so those two families are sort of going to diverge and have their own specialties, their own inference, their own requirements, and their own set of tools and techniques. And when that really crystallized for us and we realized this is where the world is going, we said, okay, let's figure out where that second group of models are going to be, what the problems are there, and let's build a product and a platform to enable that world to be easier.
So I'm curious, man, I just feel like I have so many questions about this now. It's fascinating. So when people use your software or another similar software, and maybe I should know this, but I don't, how with someone's model, let's say an LLM, they want to test it and see how accurate it is, do they get a stamp of whatever it is, whatever the grade is, and then they're done? Or are they having to continually test? Like, do they come to you, get a grade, and they're done? Or is it an ongoing, continually testing?
That's a great question. It depends on what the client wants and how much they're willing to spend. So when we talk to people who use evaluation models or models as a judge in their systems, we've seen sort of three primary usage patterns for testing and evaluation. I'll rank them in order of most common to least common, and also least expensive to most expensive. So the first is regression testing, right? Regression testing is just like normal regression testing that you do with models, or you kind of think of it as like CI/CD for coding. Essentially what some startups are doing right now is every time they make a slight tweak in the code or a slight change in the prompt, they switch out the retrieval step or something like that. They run an evaluation model on a set of like 100 examples. And they say, hey, run through these 100 examples, produce 100 outputs, and then give me scores on these 100 outputs. And that allows you to sort of baseline, just generally, okay, with every production change I make, is my system getting worse or better? Am I not, breaching a floor of performance that I'm expecting? So at least I know this thing's not completely broken, right? And so that's like a batch, asynchronous, and cheaper process because it's a lower latency and lower volume.
Yeah.
The second usage pattern we've seen most often is, I think, sort of what you're alluding to, which is production monitoring. And so some people are like, hey, we have this evaluation model. A big thing about evaluation models is they're real time. So what can we do with that? Well, we can just plug that thing in next to the actual outputs, right? Every time my agent gives an answer, I can just have the evaluation model grade it real time. And so people are using that for two patterns. Either one, if they're really risk averse, they're using the evaluation model almost as like a firewall, and they check the answer and they block it if it's not good, or they let it through if it is good. Or two, they're using it, they let the answer through every time, but they're using it more like a monitoring tool, right? They're just getting heuristics and tracking whether, the system is generally performing well with real-time outputs. And so that's the second and less common because it's more expensive, right? You'd basically be, doubling your inference cost on every call, and that is oftentimes not scalable yet. The last pattern, and this is related to AI agents, and this is new, but we're starting to see this pattern more and more, is something that we're calling with our customers evaluation nodes. And so these last two patterns I've given are basically like single point examples, right? It's where like there's one LLM output and you judge that one LLM output.
Yeah.
With AI agents, typical AI agent patterns include multiple LLM calls chained together, right? In an organizational system. And as you can imagine, if you have an AI agent that does 5 tasks to collaborate on one output, you need to judge each of those 5 tasks independently and then judge the output independently. And so we actually talked to one company. It was actually an AI sales agent tool. And they create an architecture where they have their AI agent do a bunch of tasks, and then they have a bunch of evaluation nodes powered by evaluation models that check each of the tasks that the AI agent does at each step and each interval to essentially, again, like validate that it's on the right path as it progresses through its chain of thought. And this is super expensive, but also super, intertwined with the development architecture itself. And we haven't seen a lot of people actually implement this yet because it's very costly. It increases inference cost by a lot, but it is also much safer. And we think, again, that's where the world's going to be eventually because AI agents are going to be the future. It's just a matter of waiting for development maturity to get there.
So where do you guys save your customers money? Because I've been very interested. Let me rephrase. I've been very pessimistic about AI agents, at least currently, for both largely because of the expense reason that you mentioned. I think that they're probably powerful AI agents are technically possible, but it's so expensive to run them that I've thought that it's probably not worth it for anyone to run them. But it does seem like a service like yours, like Halluminate, can alleviate some of those costs. So, you guys, obviously, without giving up too much of your secret sauce or whatever, or do you do some sort of batch processing, or how do you guys save them on inference costs?
Yeah, great question. Actually, counterintuitively, people don't care about cost in testing yet. I think
interesting.
And so what I mean by that is, so everything I've framed up to this point is about cost. But honestly, cost only really matters if you're actually able to get a testing system that's reliable. And so if you think about testing, right, the priorities of testing are, one, you need the testing to be accurate. Otherwise, the results are useless anyway. Right. And then 2, it's cost. And then 3, it's latency, because testing you can usually run batch and asynchronously. Right. So the fundamental value we're actually helping customers generate right now is we're trying to help customers build more trustworthy, reliable, and accurate evaluation models. And what that means, more technical, measurable terms, is we measure trustworthiness as human correlation or human agreement with human graders. And so what that means is, like, if you have 100 labels, 100 outputs, and you and I go grade them, and we say, hey, these 50 are good, these 50 are bad, right? And then you ask another evaluation model to do it. If you just use an evaluation model out the box, a naive implementation, I think the agreement's probably around 60 to 70%, meaning a model only actually agrees with your 100 scores 60 to 70% of the time. If people want to scale evaluation models and use it in, large scale, streamlined and automated testing, that number probably needs to be close to 90 or 95%. And that's where the hard work of tuning the model, iterating it, doing some really cool technical work and really cool technical research is to build that human correlation score higher. And I think that's the value we add. And that's what we're trying to do. Because think about it, if you have an evaluation model that is, say, even 90% correlated with a human grader, then you can start to streamline a lot of the testing processes from the beginning, right? And so it starts with getting a model to that point of performance. But then, Spencer, to your point, that's where, like, okay, now that we're here, how can we start to quantize this thing, decrease the size of this thing, decrease the cost of this thing? And I think that's where sort of the orders of priorities are. But I'd say that first step of performance is still an unsolved problem. And that's what we're trying to help our customers do at the moment.
That makes a lot of sense.
Interesting. So have you seen, maybe not cost savings, but have you seen time savings yet? Or is it still quite time intensive
Yeah.
to build these and test these and
Yeah.
implement them with customers.
Absolutely. There's definitely an initial upfront cost in creating these systems, but we've already started to see some time savings with our customers. I'll give you an example. One of our customers, they're building, a retrieval augmented generation system. So it's not an AI agent, but similar issues, right, with non-deterministic outputs that need testing. Beforehand, this engineer, she was basically, upon every deployment, checking a checklist of 100 question and answer pairs manually every single day, burning about an hour, 30 minutes to an hour every single day after she did her dev pushed to production, and then ran these tests and we're skimming the answers, right?
Wow.
You imagine 30 minutes to an hour every day across like 6 months. That's hundreds of engineering hours that are being burnt on testing, right? So we want
not high quality testing either.
Yeah, no.
Exactly.
Yeah,
absolutely, and it's a great point. It's like if anyone's ever been a data labeler, your mind goes numb. You kind of just start glossing things over, right?
Yeah.
And so we worked with them to develop, a really high quality, trustworthy evaluation model that was, highly correlated with their grading. And even if it wasn't perfect, by building this evaluation model, they were able to implement it with their deployment push, almost like a CI/CD, and use it to start filtering good and bad answers so that she could focus her efforts on the ones that the evaluation model flagged as problematic and focus her efforts there, and then let the model sort of, check the 90% that were obviously good, right? And so, we were able to bring her testing time from hours down to minutes, right? And so that's where you start to see the initial gains in engineering hours saved, and also just like you said, Spencer, reliability, right? Time saved.
Yeah.
And as you increase the performance of that model from say 90% correlation, 95% correlation, and 98% correlation, which is the holy grail, we're not there yet. You can start to trust it a lot more and more, right? And then you can put it in monitoring situations, real-time check situations, things like that. And that's where I think the really cool value comes from. An even larger, customer value is derived.
So you say 98% is the holy grail. Do you think reaching beyond that is just unrealistic, or do you think it's just not worth it? Is that kind of where the value sort of tails off?
Yeah, that's sort of just a number that I pulled out of my head. I think 98% has not been reached, I think, in any research in terms of human agreement. If you actually look at the research, humans only agree with other humans at like a 96 to 97% clip. So like,
I'm surprised it's that high.
So
yeah,
exactly.
Seriously.
And so it's right. It's totally task dependent. And so I'm saying these numbers just more so as like a heuristic for like, I think,
gotcha.
The 80-20 rule, right? Like I think it's hard to get to 85. It's even hard to get to 90. It's probably going to be very close to impossible to get to 98, 99. And so I think the whole thing with evaluation models, and I think something that I'm trying to push our customers to understand is that the systems will never be perfect. It's really just about being able to get to a number confidently and knowing the risk factor of it being wrong and then making a calculated decision, right? Yeah. It's like, we just need to, when people say they want a perfect system, they don't really want a perfect system. They want to know how often it's not perfect and what the cost of it being not perfect is. I think that's a big reason why testing is so important for deployment. It's because it allows people to arrive at a conclusion on the risk of deploying this thing and the likelihood of it messing up. And without that number at a consistent rate, how can you expect big companies like banks to deploy this thing at scale, right? Because they can't make that trade-off decision internally.
That's so interesting.
Yeah, and like to your point, like, we've spent hundreds of years trying to develop really accurate employee performance metrics, if you will. And I think that like it's a fundamental shift for people, I think, because, you don't really think of your technology as having to need imperfect metrics to follow. You're so used to everything on your computer being, perfectly interpretable, perfectly deterministic, that it's really a pretty drastic mindset shift for a lot of people.
Yeah. Well, and I think it also shows how different this technology is. Like that's what makes it so unique, right? Makes it artificial intelligence. Like it is different. You get different answers. It's unique.
Totally.
Yeah, it's fascinating.
Weird quirks.
Yeah. You guys really hit on like the fundamental issue, which is, I think, actually my co-founder Wyatt came up with this term. He says, we've entered the age of probabilistic programming. right? Which is programming is no longer deterministic, it's probabilistic. And it's kind of an uncomfortable shift, especially as most software structures and software stacks are built for deterministic programming. But once you make that leap and you say, okay, we're in the world of probabilistic programming, first you ask, okay, what does that stack look like? And you're already starting to see that stack emerge, right? Like you have vector DBs for memory, you have things like Langsmith for orchestration, things like that. And then we're focused on the testing layer. And our fundamental hypothesis, probabilistic programming requires probabilistic testing, right? You can't get like simple true-false determinism anymore. The best thing you can do is you can get a gradient and you can make a decision based off of that gradient on how your system is performing. And so I think like using things like evaluation models will also take some time because I think there is just sort of just like a general comfort there that we'll just have to wait and let the community evolve into. But like you guys hit a spot on, which is like it's an uncomfortable position to be in until you are really settled and understand where and how you have to operate.
And it's such a wild new world out there. I'd be interested. So with how long have you had like an active product now with Halluminate?
Yeah. So funny you ask. We started this company 5 months ago. We actually pivoted our product about a month ago, July 4th. And everything you see now is built from scratch since July.
Wow.
Classic startup story.
I know. I can go a little bit into like what our original product was, but working product and application, we actually launched it yesterday. So as of this interview, what we could demo in a second was launched by engineering team like last night or 2 nights ago at this point.
That's amazing.
But
congrats.
Thank you. Yeah, the timing worked perfectly.
Yeah.
But yeah, our previous problem space that we were attacking, it was the same problem. But previously, what we were essentially building was a data labeling platform. And it was actually to solve a similar problem, but upstream, which is creating test data, right? So if you think about it, like when you regression test, people need to create ideal question answer pairs. And that was the initial problem we were attacking. We're like, okay, people need to create data sets to test against. This is really hard. And this has always been hard, right? Data labeling has always been hard. How do we streamline this process? And so we built a whole data labeling platform and we try to show it to users. And we noticed really starkly that a lot of people had this problem and a lot of people didn't have this problem. And we were figuring out like, hey, why is there such a sharp contrast? It was like 50-50 on like, this is a problem or no. And we realized that data set creation is only a problem if, you either A, don't have the data, obviously, or B, it's only a problem if you don't have the data or you haven't created it yet, right? And so that means that once you create a data set, the issue doesn't go away, but it diminishes a lot, right? If you come up with 1,000 question answer pairs, then yeah, there's still some maintenance work to like groom that thing and keep it, up to date on your requirements, but the bulk of it's already done. And so we quickly realized, hey, creating a test data set's actually not like a long-term business issue, right? Because everyone's having this problem right now because everyone's trying to scramble to build something. But once they build a test data set, it often, one, the problem goes away, or two, the test data set ends up actually not being worthwhile because real users are never how you expect them to be, and the data you create is never how you expect it to look, right? And so we were like, okay, this actually isn't the biggest problem. Where is the bigger problem? And we realized the bigger problem is actually, to what we're doing now, the continual testing process against that data, the continual review process through development, production, monitoring, right? That's like the big crescendo that no one's really looking at yet because everyone's still too busy labeling data. And so we said, okay, let's make a pivot and figure out what that world looks like, figure out what that solution space looks like and build around that. Last reason is honestly the data labeling space is also very crowded now. There's a ton of hyperscalers and we realized that it would be hard to compete in terms of cost and product in that space out the gate. And so we had to find a different approach angle.
Yeah. Did you say you had a use case or a demo you could show?
Yeah, absolutely.
I'll have to drop out early. I should go do my family stuff, but I wanted to at least make it in for most of it. Jerry, it was really nice to meet you. I'm really excited to see where Halluminate goes because like I think that I was talking about this with someone on Twitter the other day that like show me an effective evaluation, I'll show you an effective agent. And I'm super 100%. Interested to see what you guys do.
100%. Yeah, great quote. I'm gonna have to steal that.
It's yours. All right.
Awesome.
See you guys.
Spencer.
We'll see ya.
Yeah, I guess we can end it with just a quick demo.
Yeah.
So high level idea is, if you're an engineer and you are trying to evaluate your system, but you are struggling to build a trustworthy evaluation agent, or you haven't built one yet, but you want to, you can come to our platform where we help you customize and deploy trustworthy evaluation systems. And so it's live on the site now. You can go to halluminate.ai and hit try now for yourself. But when you log in, you'll get a screen that looks like this. And essentially, this is what we call the criteria playground or the model playground. And this is where you as an engineer or a subject matter expert, because we actually designed this to be a low code so anyone can build one. You can try to build your own model as a judge evaluation model system. So here's just sort of a playground. And you can see this is just sort of like a demo, right? And right here, I have loaded up just a pre-built tone evaluation model, right? So this evaluation model essentially checks the output for tone. And it gives you a score based off of if it's respectful or if it's rude or unprofessional, right? And so the text here is supposed to simulate the text that you are judging against. And so let's say I had some text that's like, hey, my name is Jerry and I love it here, right? You hit run, you get a score. It's a confidence score between 0 and 1, and it comes with an explanation on why the evaluation model gave that score, right? And so you see it gave a score. It says, while not overtly rude, the tone is too casual for professional settings. A more formal greeting would be appropriate, right? And so this is honestly, a good first pass. And so as a engineer or as a grader, I can say, okay, I can either say this is a good or bad score, and we'll log that and help you correlate it over time. And you can try something else, right? You can be like, hey, screw this. I hate it here, right? Let's see what that does. Okay, it's 0, right? And so you can start to see it's able to classify along a spectrum what it believes these responses are based off of the guidelines that you gave it in the UI.
So the score is saying 1, you said that the range being 1 being this is totally professional and appropriate, 0 being totally inappropriate and unprofessional.
Exactly. And so the value here is one of the big problems we've heard from our engineers is that building evaluation models are hard, specifically because 1, they're not trustworthy. It's hard to check if they correlate with humans. And 2, oftentimes it's not you, the engineer, that tests or defines the criteria. It's a product manager or a business expert or a subject matter expert, right? And so we've built this platform with both those requirements in mind. 1, with this testing interface where you, along with a subject matter expert, can start to test and rigorously assess the judge, right?
Yeah.
You're judging the judge, which is a little meta, but that's sort of, the nature of the problem here. And then 2, with this low code playground, we're trying to incentivize PMs, business people, subject matter experts without coding experience to be able to design their own evaluation criteria.
Yeah. And it's super user friendly for sure.
And then as the engineer, you can actually look into the code itself, and figure out how to deploy this thing. You can tweak different models, set different temperatures, and that's where the engineering side comes in.
Yeah.
And then you can come here, and once you feel like a system that really effectively reflects what your criteria are and what your subject matter experts want, and they trust the outputs that this judge is producing, you're going to go here and hit deploy. And you'll be able to, copy this code and put it into whatever system you're using, and have it either as a listener or as a tester or in CI/CD, etc. And the last pillar that we want to really build our product around is ease of use for engineers. We want to take away all the infrastructure, all the unnecessary implementation problems, and we just want to make it as easy as one click, one copy, and you're off to the races.
Wow. This seems user friendly. It seems like a really, really great model. I'm curious. Thank you for showing that. And you said this is available on the site, halluminate.ai, for those who want to play around with it.
Available for anyone to use today. We're shipping really fast. Please email me if you have any feedback. We're already getting tons of great feedback. But if you want to give it a shot, it's on the site.
Awesome. Okay. We'll drop a link in the description so people can go play with it. One question I had before we end, we've talked several times with other founders and those in the AI space about regulation, and particularly like government regulation, or just where it's kind of the Wild West right now. People are just scrambling. How do we regulate this thing that's continually changing and evolving? I'm
Yeah.
curious, with you building this evaluation tool,
Yep.
it seems like this could be where regulation is going, right? Where it says, if you're going to deploy a model, it has to get this grade. You know what I mean?
Yeah.
Like, this is the first time I think that started to crystallize for me, where I'm like, okay, I'm starting to see
Yeah.
how regulation could work with
Yeah.
AI. I don't know if you
Totally.
have other thoughts on that. It's interesting.
No, that's an awesome thought, and I totally agree. I think there could be a world, this sounds even more meta, where regulation on AI is being enforced by AI regulators, right?
Yeah,
And
yeah,
it's like it's a tandem of AI regulators and real regulators, because if you think about it, there's just no way in a future where there's probably billions or hundreds of billions of calls going everywhere for
right.
humans to be able to effectively audit that at scale. And
Mm-hmm.
so you need
Right.
some form of, human in the loop automation to do that. And I think evaluation models are absolutely, in that solution space. Totally in line. And actually, we had a similar hypothesis for potentially where business value could be generated for a tool like
Mm-hmm.
this.
Yeah,
Our team actually did a research sprint to that, and we were trying to understand the state of AI regulation today and where it was going. I think bottom line right now, at least in the United States, there's just nothing formalized yet for us
right.
to build around, right? It is still super high up in the air. I think regulation has sort of fallen into two camps. You have the regulation that came pre ChatGPT, and now you have the regulation that's coming post ChatGPT,
Yeah, so
right?
different.
It's so different. And a lot of the regulation that I think banks specifically, because I was at Capital One, what our risk team was working off of as like a playbook was regulations that were applied to the old generation of AI that didn't
Okay.
quite fit the mold of what these new models were doing, right? It was like,
Mm-hmm.
like it was kind of things like check the data and make sure the recommendations are in line with the biases that we set out. And it's not quite a good fit, because with a lot of these models that people are using today, people don't have access to the data. People don't have access to underlying training. They just use it as an API call, right?
Interesting.
And
Yeah,
there's
yeah.
more governance on the output rather than the training data itself, I'd argue. And so
Yeah.
I think our team came away with the conclusion that at least for the next year, it seems like there's nothing actionable to build a product around, because no one knows what the actual action,
Right.
the landmines are. But secondly, you're starting to see some things emerge. I'd say, like, in terms of the old school train of thought, the National Institute of Standards, NIST framework, they've got some really interesting guidelines on how to govern generative outputs. And then California, being the progressive technology fork state
Right.
they're coming out with some pretty cool regulation. I think it's called regulating like frontier intelligence models or something like that, where our team thought that was the most clear-cut regulatory stance on generative models.
Okay. Yeah.
And I think the main things that they outlined that were relevant for us was that they actually called out the need for third-party auditors
Oh, really?
to check
Interesting.
AI outputs. And they also segmented regulation only to companies that are deploying AI of a certain scale, of a certain size, which makes sense, right? They also want to keep innovation going, things like that.
That makes
So
sense.
super interesting. I don't have an answer. I think my answer is like, I totally agree. I don't think there is an answer yet, but I think we have to look at like the few leading frameworks that are coming out the door
Right.
and try to just like extrapolate where it's going to go.
Well, that's exciting. It seems like you're well positioned with the current need, and also potentially the demand for your product could become fairly, what's the word? Not elastic. Constant. A constant demand if all of a sudden there's regulation.
Knock on wood, and hopefully it'll come out. Yeah.
Yeah, exactly. That's awesome. I guess you have time for just like two more quick questions.
Yeah, go ahead.
Okay, one, I'm just curious. You're in this space, evaluation, you're seeing so many different companies. Do you think there is an AI bubble?
Good question. I think if you talk about AI bubble in terms of like economic input, given the value generated today, up to date, then yes, obviously, right? Because these systems are still so early, that value is still being created as different layers of the stack are being matured.
Yeah.
But if you think about where it's going to be in 10 years, which is, I think, why some of these evaluations are not a bubble, I'd say no, because it takes a while for these systems to really mature. People, I think, assume that it's easy to build them at scale. And I think specifically with this AI bubble, AI, not bubble, AI like moments,
Mm-hmm.
it's really easy to spin up a proof of concept. And so people assume, oh, like this thing is kind of working like a demo. This thing can be launched tomorrow and will generate millions of dollars. That it doesn't work like that, right? Like just because it looks really nice in like a sandbox environment doesn't mean it's going to be able to scale easily in the next month. And so I think there's a fundamental disconnect right now between what people think is like, it's the 80-20 rule, right? Like it's really easy to get 80% of the way there, but it's really hard to get the last 20%. I think people are kind of realizing that and they're losing steam because it's taking longer than expected. And I do think there will naturally be some sort of rebound in terms of just like pure valuation and stock market price. That's what people consider the bubble. But I think in terms of like steady value generation, that's where the hard work is. And that's where, we're going to need companies to really do the grunt work of fixing the little problems and getting the performance up percentage point by percentage point.
I totally agree. It's comparing it to 2008, the housing market bubble. It's like it's different because in 2008 what caused the issue was those securities it was based on were inherently not as valuable as they thought, right? Whereas AI, I go back and forth whether to call it an AI bubble or not, kind of what you were alluding to saying, because there is inherent long-term value here. It's not that we're overvaluing it. It's just currently what's going in isn't exactly what's coming out, right? There's just this huge inflow and not as big of an outflow yet.
Yeah.
But it'll be interesting in the coming years.
I think another really interesting perspective I heard from someone in my network, I forget who it was, I wish I could give them credit, is that oftentimes people measure ROI by often like increase in revenue or decrease in time for something like that, right? It's really interesting because often, like, let's use call centers as an example, right? Like there's an assumption that AI can decrease call center times from say 600 seconds to 500 seconds. That's only true if you're able to accelerate every part of the process. And so if AI is making like step 3 of a 5-step process faster by 100, like 10x, but everything else still takes the same time as usual, then you're inherently going to see a very muted gain in the end result. And so you kind of have to wait for those automations to, process to all the other bottlenecks in the full chain. And then once steps 1, 2, 3, 4, and 5 get, this magical technology built into it in a reliable and scalable way, then one day you're just going to see this thing drop by like 5x or 10x, right?
Yeah.
It's oversimplified, but I think it really just goes to say like, there's a maturity in terms of the technology stack, but there's also a maturity in terms of like the application stack and like the way that's deployed. And you just kind of have to wait for all the wheels to lubricate before you see this engine roll.
Makes sense. Awesome. Well, I guess to wrap things up, if people want to follow you, Halluminate, what are the best ways for people to do that?
Yeah, totally. Follow us on LinkedIn. You can follow me at Jerry Wu or our LinkedIn page. You can also shoot me a follow on Twitter. We have a newsletter on our website that you can sign up for as well.
Nice. Okay.
We're gonna start sending those out on a pretty frequent basis. But I'd say just go to our website, try it out, and shoot us a LinkedIn follow and follow our journey as we figure this thing out.
Awesome. We'll drop the links below, so check it out. And thanks for coming on, Jerry. We're excited to see where this things go in the coming months. I'm sure it could be some big changes. So we'll have to have you on maybe in a few months and see where things are at.
Absolutely. Yeah. Anytime. Good luck with everything here. And thanks for having me on, guys.
Awesome. All right.